Uniform convergence. In this chapter, we will see convergency of function only, but that function collection of sequence of function and collection of series of function. Just now series of function we saw power series. Power series convergency we saw. Can tell that power series is one method for finding any series of function convergency, and that method is uniform convergence method. That we will see last. So uniform convergence, how we saw continuity and uniform continuity difference. Like that convergence and uniform convergence different. Here also we have to see that collection of sequence of function is convergent at which interval. We have to approach till. Maybe by approaching fail also possibility, so not convergent, not uniformly convergent. We saw before, this is the sequence. One, yeah. And this is a sequence of numbers, real numbers. Okay. But suppose if I will give x by n, and here after n natural number I will put, then this is the sequence of function. Okay. So this is the difference. And about this we are going to discuss in uniform convergence chapter. If this is the sequence of numbers and this is convergent, converges to 0, any number. This is the collection of function, and this is convergent or not we have to verify, and converges to which point will come, that point is called a function. Because this is a collection of function. So converges to also any function only, no? This is the x. X by 2. X by 3. X by 4. X by 5. So like that infinite number of natural number if I will put, then this what will happen? Closer to 0. So this is also convergent, and convergence to our here limit point telling, here limit function tell, and that function is a 0 function. And function means constant function also possibility, non-constant function also possibility, means variable form. Suppose I will choose x plus 1 by n. So this is the collection of x plus 1, x plus 1 by 2, x plus 1 by 3, like that. So this where will converge? Converges to x. Our this function itself. Our x is any value. Suppose you want how to think about x. X is any interval. In this case, x everywhere, this side also will closer to 0 will go. Everywhere converges to 0, full R minus infinity to infinity. This is our x function, this. This is our x function. This is x plus 1, x plus 1 by 2. So just x plus 1, suppose that this is x plus 1. Just extra one value. Suppose x is equal to 1. So 1 plus 1 means 2 only. So whatever x point you are getting, suppose at 1 you are getting 1, then x plus 1 means at 1 point will come 2. So like that graph will increase. So this is the x plus 1. Hereafter our every points x and in between will come, because this will decrease and will asymptotes will prepare with this x. Asymptotes means will mix, will lie on that curve. So what will happen? This is the x plus 1. Next, x plus 1 by 2, x plus 1 by 3. This is minus point, no? So like this will happen, this type. Understanding what I am doing? This type. This closer to this x, this closer to this portion, negative portion and all. So finally, infinite number of natural number when I will put, then our this is converges to this x. Understanding? So this is convergent and converges to f of x. And what is that f of x? X. Whatever interval means this you will get. If x value you will put, then x every value will cut. Means suppose your interval is 0 to 1. Natural number also you are putting. X value also you are putting. Then your x value will come between this to this. All x value will come. All 0 to 1, everything will come. Okay. X value still I am not putting. Your mind may be running x value will put means what will happen. I am putting only n value. I want to show you when we have n natural number I am putting here, then this is the sequence of numbers. So converges to any number only. But natural number I will put here or here, then this is a collection of function. And this collection of function is convergent, converges to any function, either constant function or non-constant function. But you see hereafter. Suppose x by n I choose. And hereafter x value I will put. Then what will happen? When x value I will put, then infinite number of sequence we will get. Correct or not? Here x is equal to 0 I will put, means one sequence is this. 0, 0, 0, 0, 0 by 1, 0 by 2, 0 by 3, 0 by 4, everything. X places 1 by 2 I will put. 1 by 3 I will put. 1 I have no place. Here I am writing. 1, same type 1 by 4 and like that. If last x is equal to 1 I will put, then 1 I will get. So whatever domain value given have, this is the domain, means x value. So x value we will put in collection of function, then infinite number of sequence of numbers we will get. Correct. So every x value, when I put in this collection of function, then infinite number of sequences I got, and every infinite number of sequence, if convergent, 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 if you are getting, then I can tell no, this collection of sequence of functions are convergent, point-wise convergent at every point on this interval. So that is called a point-wise convergent. You can see 0, 0, this is convergent, converges to 0, converges to 0, converges to 0, converges to 0, converges to 1. Understanding? So on this interval, this collection of sequence of function convergent have at every point. So this is called a point-wise convergent. Next concept, we will see on this complete closed interval 0 to 1, our limit points what we are getting. Limit point, every place is same have 1 means 1 by n. No. sorry. I direct 1 I put. So here x plus 1 means 1 by n, so 0. So next we have to see if this is a point-wise convergent, then point-wise convergent converges to where? What is that our limit function here? Either limit function is a constant function or any function defining. Correct. So we can see our limit point are same 0, 0, 0, 0, 0, every places have. So here limit function is 0. So we can tell this sequence of function is a point-wise convergent on closed interval 0, 1 and converges to limit function is 0. So when we are getting this limit function fx, this is now here after on this complete interval. Now how I will write, you see, x by n converges to f of x. What is f of x? 0, where for all x belongs to 0, 1. This type I will write here after. So on complete interval, our limit point what getting? This function what have? 0. Understood? Suppose sometime possibility have that our limit point different coming. Possibility have x value I put. Don't sleep. Time what? 1:33 only. 10 minutes have. Hungry coming. Don't sleep. Sleep coming little. 10 minutes I will live. After that eat and sleep. Let's click on class. Till here don't eat. So I was telling, when x value domain points 1 by 1 I am putting in x, possibility have no convergent, but separate limit point, 0 getting 1 getting 2 getting 3 getting, like that possibility have. So when distinct limit points coming, then we have to see, we will tell no problem that our point wise convergent, if for at least one point, if divergent coming, then we will tell not point wise convergent on that interval. Whatever x value I will put here, every point convergent have to come. Then we will tell given collection of function point wise convergent on this interval. Understanding? If at least one point I am putting and not convergent coming, means no point wise convergent on this interval. Okay. If point wise convergent have, every point convergent have, limit point unique coming, then this type we can write. If limit point, suppose limit point, we have any function of x and our fx separate came. Suppose 0 coming, 1 coming, 2 coming, 3 coming, like that, increasing between whatever values are there. So more than one limit point have. More than one limit point have on that interval. Sometime what will happen? Complete function form will come. That is different. What I am telling, try to understand. Suppose I will define, otherwise you will get confused. Suppose I wrote 0 to x less than 1 by 2. I got 0. 1 by 2 less than x less than 1, I got 1. And x is equal to 1, I am getting 2. Like that, suppose that, like that, 3 types of limit coming, 0, 1, 2. Means on this sequence, x place between 0 to 1 by 2, anything putting 0, 0, 0, 0 you are getting. But again, between 1 by 2 to 1 you are putting, then 1, 1, 1, 1, 1 getting. And x is equal to 1, 2 coming. So this complete, on complete interval function type I can't write, no. Any function I can define this? This is x function or anything? Can't define any function, I can't define. Wait. Suppose, again I am writing another function, then you can understand. This fx, I am getting between 0 to x and 1, whatever value you are putting, same getting. Means I can write no x itself. 0 means 0, 1 means 1, 2 means 2. Whatever you are, 1 by 2 means 1 by 2, 1 by 3 means 1 by 3. So between 0 to 1, same to same if we are point getting, then meaning x itself, x function. And x is equal to 1 plus also 1 getting. So this is full x function only, no? So I am telling that I can't convert this is any function form, no? This is fx is equal to x. I can tell, I can't convert. Understanding what I am telling? I can't tell that between 0 to 1 by 2, 0, only 0, 0, 0, 0 going on. Between 1 by 2 to 1, 1, 1, 1, 1 going on. And between x is equal to 1, 2 have. I can't convert in any function form. If I can convert, suppose that I wrote, that is the x function. So x function is continuous only, no? So that is the one limit point. Full function is a limit point. But here limit point is not unique. On complete interval, 3 types of limit point define have. 3 types of limit point I am getting on complete interval. But that place, you don't think that x is our complete limit point. Don't think they are also distinct have. That is distinct not. That distinct same to same coming only x function preparing. Understanding? So when x function coming, then that is a continuous function on complete interval 0, 1. But if this structure will come, then this is a discontinuous function. More than one limit point will define on complete interval. After limit function f of x, I can tell no, this is a discontinuous on closed interval 0, 1. But that is a continuous limit function on closed interval 0, 1. I can define. So discontinuous means more than one limit point on that complete interval. Continuous function means that is the full continuous limit function that is. Okay? Understood? And both case point-wise convergent, no problem. I can, this is the point-wise convergent, converges to discontinuous limit function. That is the point-wise convergent, converges to continuous limit function. Okay? Understood? Next. If point-wise convergent have and converges to discontinuous limit function getting, then direct tell never uniformly convergent possible. Because uniformly convergent means we don't want any trouble problem. Because our limit point itself undefined can't tell. I want uniform means unique limit function. Means our on complete interval, unique way have to go, means continuous limit function what. Discontinuous limit function means that is not possible for uniformly. Because I can tell by our language on that domain, limit function have more than one limit point. Like that you tell. I can't change in function, continuous function. So that is a more than one limit point, not a unique limit point. So uniformly convergent, finish. But continuous limit function, if you are getting, then may or may not be uniformly convergent. We have to verify next. Maybe any place x I will approach anything and fail will go. Understanding? So if continuous limit function coming, then may or may not be uniformly convergent. Discontinuous limit function coming, direct without calculating, you write not uniformly convergent. No need to proceed anything. Okay. So this is roughly discussion. You can write also. Next definition and all I will write. Time also after the definition I will write. This right, but this is just roughly discussion. Right, everybody. Right after that, after lunch, we will see. but this is not JAM syllabus. But in future, CSIR and I'll have to write must. That time I will use. But other university exam writing, no, Pondicherry University or nowadays that CUET and all started, must will come. Except JAM, every places have. NBHM, TIFR. This is the graph of x plus 1 by n. That is the graph of x by n. You can write. This is the x plus 1 by n. This is the x by n. Finished everybody? Okay, after lunch.